Welcome everybody to today's Luohan Webinar. Today we are super excited to introduce a new friend to you, Professor Karthik Sastry from Princeton Department of Economics and also the School of Public and International Affairs. So Karthik is actually a macroeconomist working mainly around bounded rationality, attention cycles, and together how to introduce the microeconomic theory into modeling the macroeconomic dynamics. So Karthik is also very interested in, the interactions between information, innovation, and also the market. So I think share really a close interest to the academy. Actually, before today's talk, we've already received a bunch of questions regarding the papers. So I think tonight will be super, super thought-provoking. And also before the start of the talk, two announcements. First one, we are gonna initiate a WeChat group for people, in speak Chinese who hope to receive our announcement and update on the upcoming events. You can directly join our WeChat group. I will send later details in the chat, and you can try to add the, our official WeChat account in order to join the group. And for those who speak English, our international audience, you can directly email the one that I just sent on the contact part, and then we will let you join our email list, which we will basically send exactly the same content for you to, receive all the upcoming events. Okay, the second announcement is that for the next 2 weeks, we are not gonna hold this webinar. So our next talk will be at the end of the May. Okay, so then without further ado, let's welcome Karthik to bring us this super interesting topic on attention cycles. Please.
Fungi, thank you so much. Thanks for the invitation and the very kind introduction. So as introduced, I'm delighted to present attention cycles, which is joint work with my colleague Joel Flynn at Yale. Business managers often make mistakes, and a classic explanation is that, well, they're only human. To paraphrase Herbert Simon, all people, including business managers, have attention constraints and bounds on their rationality that prevent perfect decision-making. Now, the original work of Simon, as well as more recent work in the rational inattention literature, has emphasized the fact that maybe we shouldn't treat bounds on rationality as just fixed constraints on people's behavior, but instead ones that evolve as people allocate cognitive effort and attention towards different tasks or different shocks or stimuli in the economy. That's the broad motivation for this paper, in which we study how the allocation of attention over the business cycle can shape their character and moreover, shape the incidents of the business cycle. So in particular, what we do in this paper is we study a two-way interaction between business cycles, which are fluctuations in aggregate decisions or incentives in the economy, and attention cycles in this realm of cognition and mistakes. We first ask whether there is an attention cycle that moves systematically with the business cycle. Next, if so, how can we measure it? And then finally, how does that reflect back and affect business cycle dynamics and equilibrium? So by way of summary, what we're going to do in this paper is first build a model which will have a neoclassical core plus one new element, which will be a costly control problem or an allocation of attention for firms. Theoretically, what we're going to show is how cognitive effort and misoptimization evolve with the business cycle. We'll start in partial equilibrium from the following basic insight, which is going to be embedded in our model and really all models of rational inattention. Bounded rationality is lower when the stakes for making precise and accurate decisions are higher. Now, where did those stakes come from in the business cycle? We'll argue that there's two main sources of incentives that are moving around. The first we'll call the profit curvature channel, which is to say that the dollar cost of making a mistake, if you hire a little bit too many workers or too few workers, how many profits do you lose? That's moving over the business cycle. And the second we'll call a risk pricing mechanism, which is losing a fixed amount of dollars has a different utility or payoff cost at different parts of the cycle due to the standard implications of asset pricing theory, which is where the name of the channel comes from. What we'll show is a sharp condition which delineates which of these forces is stronger and determines whether the attention cycle is pro or counter-cyclical. We'll argue that the GE prediction under a reasonable calibration is going to be counter-cyclical attention or low misoptimization in high attention and downturns. That'll be a testable prediction that we can take to the data. So what we're going to do in the next part of the paper is propose ways of measuring businesses' misoptimization. That's going to be a very model-based approach. as well as their attention to macroeconomic developments. That's going to be a language-based approach that, if you'd like, is a more model-free test of the broad hypothesis. And that'll allow us to show the following findings. First, as predicted by the theory, misoptimizations are smaller in downturns and larger in booms. Second, towards this mechanism we're emphasizing, that incentives drive all of this, we're going to show that financial markets punish firm-level misoptimizations more when the aggregate economy is doing badly. That's exactly when, from the perspective of your stock price, you really don't want to make a mistake. Next, firms' attention to the macroeconomy measured in language rises in downturns and falls in booms, consistent with our hypothesis. And then finally, the firms that are attentive by a language are also the ones making smaller misoptimization, which suggests that our two methods of measurement are really aligning with each other on the micro level. What we do in the last part of the paper and this presentation is we go back to the model and try to ask, if we have realistic attention cycles, how does that affect business cycle dynamics? The main answer is that it generates endogenous business cycle asymmetries. The whole economy is more responsive to shocks in those states where individual business managers are more precisely responding to shocks. And just to give a sense of magnitudes, our mechanism calibrated to the data will give endogenous countercyclical volatility and output growth, which when calibrated to the US is about 20% of what the data asks for if you run a hidden state or GARCH model on US GDP. So, the outline of the presentation will follow that broad outline, starting with the model and the theory, then measurement, empirical results, and the quantitative results. So let me jump into the details of the model. So I'm going to start with the block of the model that's most conventional, which are going to be the households, the final goods producer, and labor supply. And this is going to follow the template of being on the backbone of a neoclassical or RBC model. There are going to be countably infinite time periods indexed by T. There's going to be a representative household which consumes capital CT of the final good and works LT labor hours, with the following somewhat standard-looking payoff, expected discounted utility. And I want to highlight that gamma is going to be the coefficient of relative risk aversion, and that's going to play a more pivotal role in the following results. There's a final good, which is what the household consumes, produced with constant elasticity of substitution technology. Epsilon will be the elasticity of demand, or equivalently substitution between the varieties, And this will be composed of intermediate goods indexed by I between 0 and 1. The final goods producer is going to be competitive and fully attentive, so too the household. In that sense, they won't be the interesting agents in the economy, but instead it will be these intermediate goods producers, which we'll zoom into on the next slide. Finally, labor is supplied in this economy such that wages are consistent with the wage rule written below, where chi is going to be elasticity of real wages to real GDP, since this model is purely real in the economy. We introduced the wage rule because, first of all, it's a realistic way of getting wage rigidity into the model. And it's going to be very useful for analytical results because it will allow wages to move 1-for-1 with GDP in the economy. In the paper, we show that if you use more neoclassical approaches, but you calibrate towards the same rigidity of real wages in the economy, quantitatively, you get almost identical results. This is truly just to give analytical formulas that are exact in this context. Okay, so as promised, let me now start talking about the intermediate goods firms, and then we'll get towards the implementation of inattention in this model. Each intermediate goods firm operates a constant returns to scale technology, where labor is the only factor of production, and theta IT is going to be the idiosyncratic productivity of firms. Those are going to evolve in a flexible firm-level Markov process, which can depend on idiosyncratic and aggregate states. The sufficient statistic that we need to keep track of is this capital GT object, which is going to be the cross-sectional distribution of firms' productivity in the economy at any given time too. There's going to be a single, as I mentioned, single labor input and constant returns to scale, but this is easily generalized to multiple flexible inputs as long as you maintain constant returns to scale. These intermediate goods firms are owned by the representative household. So at the risk of being slightly pedantic, I want to emphasize that this capital pi object, we're going to use a bunch in the next few slides, is firms' flow payoff from the household's perspective. And it's the product of two terms. The first is this little pi function, which is the dollar profit of the firm. So that's how much they produce times the markup, price minus marginal cost. It's a function of how much firms produce, which is little x, their productivity theta, aggregate demand, capital X, because of the aggregate demand externality and the demand curves. And finally, the wage that they paid, the factor price for this firm. The second term, which we're calling capital M, is the marginal utility of investors, and that you can think of as the utils per dollar, such that capital pi, the payoff, is correctly in units of utils, not dollars. And in this case, because of constant relative risk aversion, this marginal utility term, or equivalently the stochastic discount factor, will take a very simple form. But this way of writing it just emphasizes that basic idea would persist in a broader class of models. Okay. So now we're going to talk about inattention and the crux of our modeling strategy here. Our premise is going to be that it's difficult for firms, or equivalently the managers of firms, to digest the state, that is to say, all externally determined variables which matter for the firm, and translate that into a decision. So to describe that a little bit more formally, I'm going to define this object ZIT, which is the concatenation of firms' productivity, aggregate demand, capital X, and real wages, W, which is going to enumerate all relevant state variables from the perspective of the firm. The firm observes Z in the previous period, and it's going to conjecture a transition density F for stochastically how this object is going to evolve. Later, we'll emphasize that is one consistent with rational expectations. So just to give a very concrete example of this, it's imprecise because we're actually working with a continuum of states, but it gives the right flavor. Imagine the state in the previous period for the firm that we're studying is the Z0 state, where firm level TFP was high, but GDP was low. So just to emphasize that there are microeconomic and macroeconomic factors in there. There might be a number of possible states for today's decision. So one could be the state Z1, in which there's high firm TFP and high GDP. And this conditional density F is going to tell us the probability of landing in that state Z1. There could be the state Z2, where there's low firm TFP and low GDP, et cetera, et cetera. So conditional on the observation of the last state, we have this conjecture for possibilities in this state. What the firm is going to do is choose a family of conditional distributions for how much to produce, which we're going to denote by P. So P of X given Z1 is a probability distribution for how much to produce in state Z1, similarly in state Z2. And the whole plan PT is this family of distributions indexed each possible state of the world. And another interpretation, you can think of this as like a conditional plan that the firm is choosing ex ante. What the firm is going to do is choose this plan to maximize expected profits, which is the standard term in risk-adjusted units, minus a cost, which is going to embed the idea that precise planning is difficult. Absent this cost, this would reduce to the standard problem under full information. It would be as if the firm could perfectly do the right thing in each state of the world. But with this cost, we're going to introduce a friction that makes precise planning difficult for the firm and create some tension about where the firm, toward what states of the world, it wants to allocate its attention and its cognitive effort. So as written, this problem is very general. What we're going to do is we're going to specialize to a specific class of costs, which take the following entropic form. So in particular, I'm going to introduce one new parameter, lambda I, which will be a firm level shifter for the scale of this cost with a cross-sectional distribution H. And we're going to introduce the cost as being negative lambda I, where lambda I is positive, times the expected entropy of these probability distributions, where the expectation is taken over the transition density. So that is to say, it's an expected measure across states of the cost is the negative of an expected measure across states of how random firms' production choices are. So we show in the paper, and we discuss in some companion works that Joel and I have published in the Journal of Economic Theory called Strategic Mistakes, that this cost belongs to a larger family of what we call state-separable costs of stochastic choice. And we think they're especially convenient for this study, as well as other similar macroeconomic works, for three related reasons. So the first is that this model is going to allow for an analytical characterization of optimal policy. So compare that, for example, to the standard model of mutual information of SIMS or other proposed models of costly information acquisition. And to our knowledge, it's not possible with known techniques in those alternative models to characterize attention decisions in a problem like ours, where the objective function is not quadratic, or that is to say, there's actually incentives to pay attention to certain states in excess of others. Second, it's going to allow for tractable equilibrium analysis. We'll be able to aggregate exactly what firms do in order to characterize properties of attention and misoptimization in general equilibrium, which we think is very important towards making a macroeconomic analysis here. And then finally, it's going to predict a realistic pattern of stochastic mistakes. And that is, again, in contrast to, say, the mutual information model, which predicts discrete actions, which we think is not necessarily a desirable property in our setting when we're studying how firms decide, for instance, how much to produce or how much labor to hire, or, for instance, other purely deterministic models like the sparsity model. So in summary, we think this is a tractable and very appealing form of the rational inattention cost function that's going to get at the core idea that attention responds to incentives, but also allow us to do equilibrium analysis and to study a problem of our complexity. Okay, so let me now just wrap up the description of the model with the description of equilibrium. So there's going to be an aggregate productivity state in the economy that will introduce to shift around the cross-sectional distribution of productivity. And this is just going to be a very simple way to create a one-dimensional RBC interpretation of our model, although strictly speaking, it's not necessary for some of the results that we show. So in particular, this theta t parameter is going to be a scalar. It's going to move up and down. And what that will do to the cross-sectional distribution of productivity is move it with respect to first-order stochastic dominance. So high productivity in the FOSD order, in the aggregate, will correspond to, in the FOSD order, an upward shift in the distribution of idiosyncratic productivity. And that we think is a realistic feature, so that suggests that our model can be consistent with a lot of the more fine-grained microeconomic work, people have done to measure those shifts over the business cycle. We'll moreover operate with a linear quadratic approximation of the profit function and the aggregator in this economy that I just want to be crystal clear about. So we'll approximate profits as second order around state-dependent optimal choices, where what's shown here is the second order Taylor approximation, and the first order term is going to disappear because those state-dependent optimal choices are optimal, so they solve the first order condition of maximizing profits. Similarly, the CES aggregator, we're going to take a second order around the optimal choices of firms. And both of these choices, again, are going to help us with analytics here, but the kinds of results in our companion paper, strategic mistakes, could be used to show our results with more generalized forms of concavity that are satisfied by the exact profit function and aggregator in our setting. Equilibrium is going to be a sequence of choices, output, and wages, such that intermediate goods firms optimize given a correct conjecture for aggregate output and how it evolves. And final output is consistent with the aggregator and wages with the wage rule. So aggregate state variables evolve as agents, as agents conjecture. Wonderful. So absent further questions, I'm going to dive right into our theoretical results. Okay. So our first result, we're going to start with the conduct of firms and then build up to the general equilibrium implications. So our first proposition is going to characterize the production of each firm in the economy. And what we're going to find is that each firm's production is described by the following random variable that has the following important features. First, it's Gaussian. Second, it's centered around the unconstrained optimal action, which we're going to denote as X star. So X star, as a function of firm level productivity, aggregate output, and wages, is what firms would do if they faced no attention constraints. And finally, the variance of misoptimizations, this Gaussian error term, is going to depend on features of the problem that we can characterize. So in the denominator here, there's two terms that I want to zoom in on. The first is little pi sub xx, which is the second derivative of the dollar profit function in the action of the firm evaluated at the optimal action. So that is to say, what is the curvature of the dollar profit function and how does it respond to small mistakes and how much the firm produces, if it produces a little bit more or a little bit less. The second is the stochastic discount factor, or the translation from these dollar losses to utility cost. And that's the second ingredient to the second order approximation of the firm's payoff function in utility units. And these two forces together embody the basic intuition from the beginning that firms' attention and misoptimization are going to respond to stakes. Attention is higher, misoptimization is lower when these payoff functions are highly curved. And from here, we're going to start to ask what determines these incentives in a macroeconomic model, and what does that tell us about the attention cycle in the macroeconomy? So to do that, and to highlight the key forces here, I'm going to define the extent of misoptimization as this M function, which is the expected mean squared error for a firm. And you get a similar definition with different measures of the overall error of these firms. And just to restate the key implication from the last formula, fix a firm's inattentiveness, the scaling on their cost. Their extent of misoptimization is going to decrease in the profit curvature, holding fixed the stochastic discount factor. That's what we're going to call the profit sensitivity channel. And it's going to decrease in marginal utility, holding fixed profit sensitivity. That's what we're going to call the risk pricing channel. So we'll identify these as the two key forces that determine when and why firms misoptimize. Excuse me. Now, in our economy, we have a more precise idea of what economic forces fundamentally determine profit curvature and marginal utility. So while the first result would be true in an economy with different kinds of production functions and different evolutions for aggregate wages, the second result is going to use our functional forms, our RBC structure, and relate this to primitives. The first aspect of this result is that the misoptimization of a firm, we're going to predict, always increases in their productivity, theta sub I. That's going to be based entirely on the profit curvature channel when firms' demand curves are isoelastic. The second is going to be a little bit more interesting for our purposes, which is that misoptimization increases in output, which is we denote as capital X, if the following condition holds, and it decreases otherwise. And what this condition does is it translates profit curvature and risk pricing into the units of our problem. On the left-hand side is the coefficient of relative risk aversion of the household, and that's always going to make the risk pricing channel strong. It's going to push towards larger misoptimization in booms and smaller misoptimization in downturns. That's because in utility terms, when gamma is high, it amplifies the cost of mistakes in utility terms in downturns. On the right-hand side, we have a multiplication of chi and 1 plus epsilon. That's going to be the microfounded version of the -1, and that's going to be the microfounded version of the profit curvature channel. And the essence of this, chi is the elasticity of real wages to output, will be that the profit curvature channel can push in the other direction very strongly if wages are very cyclical in the economy. That would make it very costly to make a mistake in a boom relative to the downturn. So this partial equilibrium result is going to encapsulate some of the key logic of what's going on in our economy. But what we can do, as I mentioned in our setup, is we can translate these results quite directly to general equilibrium. So that's what we're going to do next. So I'm going to introduce the following assumption, which just for brevity, I'm going to introduce as assumption star, which has two components. The first is going to be that the coefficient of relative risk aversion exceeds 1 plus the elasticity of real wages to output. And the second is going to be that the product of that elasticity of real wages to output times the elasticity of demand, or the elasticity of substitution between the products, is less than 1. Now, I want to add that empirically, we might expect both of these constraints to be quite slack. So if we believe more non-parametric estimates of the stochastic discount factor, as well as the observation that real wages in, say, the United States, just to use that example, are extremely acyclical, then the coefficient, the condition on the left is simply requiring that the coefficient of relative risk aversion is above maybe 1.3 if we're being very generous, to wage cyclicality. The second condition, again, is very slack under rigid real wages, but otherwise it's disciplining that strategic complementarity in the economy is not explosive. And in that sense, we think almost any sensible model in this class would have that condition. What we can show is that under assumption star, there's going to be a unique equilibrium with positive output X, and moreover, in which output is strictly increasing in productivity. So that is to say, productivity is this non-parametric shifter of the microeconomic productivity distribution in the economy. It can encapsulate shifts not just in averages, but also in volatility, as long as they're consistent with first-order stochastic dominance. And under assumption star, the economy is going to move in a monotone way as productivity, defined in the aggregate, goes up and down. And then finally, under assumption star, restated here, the unique linear quadratic equilibrium is going to feature lower average misoptimization when aggregate output is lower. So what this result composes is the proposition above, showing existence, uniqueness, and monotonicity of equilibria, with the fact that the assumption star, which I just argued is empirically realistic, is actually sufficient for the discussion on the last slide for the risk pricing channel to dominate. It takes just a very small elasticity of marginal utility to aggregate output in the economy for that to be the case. So this backs up the claim that I made earlier in the introduction that what we consider kind of a standard calibration of macro financial variables is going to be consistent with our main prediction of misoptimization cycles. Wonderful. Okay. Now, the second broad goal of the theoretical exercise here is to understand how the attention cycle affects the business cycle. So statically, there's going to be a mechanism in our model that's familiar from some related studies of attention and general equilibrium. When firms are inattentive, they're making choices that are random, they're not related conditionally on productivity, factor prices, or other fundamentals. That's going to lead to misallocation in the economy. Some firms are too big, some are too small because of mistakes made by business managers. And under a concave aggregator, or under kind of the standard notion of substitutability between products, that's going to lower output and lower productivity in the economy. What we showed on the last slide is that there's cyclical inattention in the economy. Moreover, it goes in a particular direction. There's more attention in downturn, less in booms. That suggests that misallocation in the economy through this channel is also cyclical. And moreover, that there might be a state-varying attention wedge, which encapsulates this channel and affects productivity differentially in booms versus downturns. So that's exactly what we show in our last main analytical result. So we're going to define two sufficient statistics. The first, without loss, will be a definition of theta, the aggregate productivity state, as quasi-arithmetic mean of the microeconomic productivities. And the second will be the average inattentiveness, or cost shifter, in the economy. And what we can show is that output can be written in the following way, where aggregate output in the economy is log linear in aggregate productivity, plus an extra term, which we call the attention wedge, which is less than or equal to 0. And moreover, which disappears if all firms are perfectly attentive. Under the maintained assumption star, the wedge is going to satisfy two intuitive properties. First, it's going to widen smoothly when cognitive costs get bigger. So when there's more inattention, there's more misallocation. And second, when aggregate productivity is higher, the wedge is also going to widen, which means that the wedge is the largest in the most productive, but as we just argued, the lowest attention state. It's smallest in the least productive, highest attention state. And moreover, we can write a very similar result for labor productivity in the economy, which shows that this is also shifted by the wedge and has the same intuitive comparative statics. So that's to say, in a world of attention cycles, the efficiency of the economy, because of cyclical mistakes for business managers, is moving throughout the cycle. And that's going to be the key quantitatively towards our predictions of business cycle asymmetries. Okay. This might also be a natural place to pause for questions. I'm sorry, I've not kept a super good measure of the questions in the chat. But I'm happy also to keep going, and I'll be able to save some time for questions at the end. Okay, I'll keep going then. Wonderful. So we've laid out this theoretical apparatus, and we've made some predictions that attention should be high in downturns, misoptimization should be low. But our next goal, of course, is to try to come up with some way of actually measuring those things. So to do that, we're going to generate a more very model-consistent measure of misoptimization, following exactly the blueprint I just showed you, as well as a more model-free measure of attention. Our baseline is going to be a data set on US public firms from the mid-1980s to 2017. So these are standard data from CompuStat. Their annual frequency, they cover multiple sectors. An acknowledged weakness is that we have only public firms here. We're going to use standard restrictions on the sample, getting rid of financial and utility firms, which we think might operate very differently. And our key variables are going to be the inputs and outputs of the firm. To go from theory to data to measure misoptimizations, we're going to make the following observations. In the theory, the amount that firms produced was equal to some ex post optimal level plus an error. What I've done here is I've just written that same proposition in terms of how much the firms hire, which is something that we can measure in quantity units in standard data. So the amount that a firm hires, log LIT in period T, is going to be centered around some ex post optimal level, and it's going to have some tremble, which is the second term, which has an endogenous variance that we're interested in studying. We know from the structure of the model that the optimal choices of the firm depend on three things. They depend on productivity. They depend on aggregate output, because that scales forces shifting the demand curve. And they depend on factor prices in the economy. Our claim is going to be we can try to take this equation as a structural equation and get at the residual and its variance in the following way. We can try to estimate firms' productivity and the responsiveness of firm hiring to productivity. We can try to use fixed effects, non-parametric trends to span out other shifters of demand at the aggregate or industry level, as well as factor prices. And finally, we can treat as a residual what should correspond theoretically to our misoptimization. That's exactly what we're going to do in the data. We're going to estimate a version of this using estimated TFP for all our firms in the sample, using firm and sector by time fixed effects to parametrically, get at these other shifters of demand and factor prices. And we're going to extract a series of misoptimization residuals, which we'll call M, and create a statistical measure of their variance in the cross-section. And that's going to correspond to exactly what we treat as misoptimizations in the data, or rather the variance of misoptimizations in the data. For our more non-parametric method, to get at this idea of attention, we need to be a little bit more creative, or go a little bit more off of the exact blueprint of the model. Attention or cognitive effort is not something that's intrinsically measurable really in any conceivable theory. But our approach is going to be to say that if we have data on the mindset or the language used by business managers, that might be reflective on what firms are paying attention to and with what intensity they are. So to implement that, we're going to take data of the full text of US public firms' 10K and 10Q filings, which are summaries of business operations written by managers and their legal teams for the Securities and Exchange Commission, the chief regulator of public firms in the US, that include extensive discussion of risks and outlooks. So we're going to have a similar sample from 1995 to 2018. And we're going to try to zero in on one component of attention that might be common to all firms, which is attention to the macroeconomy. Almost by definition, that's something that affects all firms in the economy. What we're going to work towards is creating a measure that scores each firm in each document, that is each firm in each quarter, based on their attention to the macroeconomy. And in brief, our method is going to build on some advances in natural language processing. So to just be very specific about our algorithm is here, what we're going to do first is we're going to build a dictionary of words and phrases that are indicative of discussion of macroeconomics, but are less common on average in the 10Ks and 10Qs. To do that, we're going to use this TF-IDF statistic from natural language processing, which is the product of the frequency of a word in a reference corpus, which in our case will be macroeconomic textbooks. So that'll be high for the words that come up a lot in the study of macroeconomics, times the log inverse frequency of words in the 10Ks and 10Qs. So that's going to be very small if a word tends to come up really often in accounting exercises. And what we do is we take the top words scored by TF-IDF using a collection of different references. And that's going to give us, in sort of an automatic and unsupervised way, a list of words that hits key macroeconomic topics like unemployment and inflation. But it nets out really standard vocabulary of, say, costs and accounting that we wouldn't want to contaminate our index. And we can define macro attention for firms at a given period of time as the total inverse document frequency, IDF weighted frequency of the macroeconomic dictionary words, and create a time series aggregate by averaging across firms in a natural way. Wonderful. Okay. So having constructed this data set on firms' attention and misoptimization, we're now equipped to test the key ideas of the attention cycles theory. And that's going to proceed through a sequence of facts that we think are all consistent with the theory. So the first is an important validation exercise. We've measured misoptimizations statistically as deviations of what firms produce or how much they hire from what's predicted by a structural model based on their productivity. We've not verified in any way that misoptimizations are bad for firms. And moreover, that's true symmetrically if they over or underproduce. So our first result is going to be based on these bin scatter plots of firm stock returns and profitability as a function of the misoptimizations that we extract from the data. And what we find are these non-parametric bell-shaped relationships, where in a way that we didn't impose in the theory, from the perspective of stock returns or profitability, the best thing for a firm is not to misoptimize. And again, that was not imposed by our measurement strategy. And if firms hire too much, which would be to the right, or hire not enough by our measure, both of those are going to correspond to negative outcomes, lower stock returns or lower profitabilities contemporaneously. Moreover, this effect is quite persistent, so that suggests that it's not a reversal that we're picking up by having too small of a time period. Next, we're going to take it all the way to the macro level, so we can calculate this average misoptimization statistic exactly as the model suggests. And we're going to find that misoptimization dispersion, this measure of the variance of misoptimizations, is procyclical. It spikes in the United States during booms, most prominently during the 1990s, which narratively lines up with that period of expansion and the dot-com bubble. It's going to fall in recessions in the United States, for instance, in the early 90s, the early 2000s, and during the Great Recession. And moreover, again, this result is not mechanical because it is actually quite different from what people have found looking at unconditional volatility of, for instance, stock returns or productivity, which tends to spike in downturns. The key difference is we're looking at, as suggested by the model, the more isolating the component of decisions that's due to misoptimizations. That's actually smaller in downturns, and that's going to be consistent with our idea of an attention cycle. In the paper, we discussed extensively that this is robust to considering a number of different model extensions, including incorporating adjustment costs in our measure of production functions and policy functions, financial frictions, estimating productivity in different ways. And then finally, to zoom in on this panel F, we do our main analysis for a smaller time period to make it easier to do the macro calibration. But we actually find very consistent results going all the way back to 1950, basically using all the data that's possible in the CompuStat sample. And sorry, I didn't introduce exactly what these graphs are showing. The left graph is showing misoptimization dispersion in blue against the US unemployment rate in the dashed line. And the right graph is showing this against the detrended level of the S&P 500, which we think of as two complementary ways of measuring the business cycle and or financial cycle in the United States. Great. So the next thing that we want to show is that there's some evidence at the microeconomic level of an incentives-based mechanism. The way we're going to do that is the following. Now we'll use our firm level panel data once more. We'll return to that idea from a few slides ago that misoptimizations are bad for performance, in this case, year-on-year stock returns for firms. But now we're going to estimate separate coefficients on the squared misoptimizations in different years. So what this regression is going to ask basically is, if you make a misoptimization of a specific size measured in terms of how much you over or under hire, when is that most disadvantageous to your stock return? That's when this beta Y coefficient will be large in absolute value. This graph shows the beta Y coefficients along with their 95% confidence intervals in different years. And the pattern that emerges from this is that it's most bad to make a misoptimization when the S&P 500 or when the economy is doing poorly. So the non-parametric method is kind of showing us a little bit the early 90s, the early 2000s, and the Great Recessions. But this is, I think, even a little clearer if you overlay the years on which the S&P 500 return is less than 5%, which would be about, I think, 25% of the sample. And you see a pretty good lineup of these when the blue lines are big in absolute value or they're low on this graph, and when the orange regions are shaded in. And this we show a little bit more carefully in a regression specification, including the interaction between these two variables. Very briefly, I want to mention that we can do the same test also looking at the profitability of firms. And according to our model, that's a complementary mechanism. This is the profit curvature channel, but it's not necessary for our overall findings. And indeed, what we find is kind of weak, more muted evidence that profits are more sensitive to misoptimizations and downturns. So combining this with the previous result, we're going to take that as evidence that not only are there incentives piling up in downturns, they seem to be mainly related to the financial incentives or the role of the stochastic discount factor. Finally, I want to more briefly go over our results about macro attention in language. We find that macro attention in language is countercyclical. So what we're showing here, in a similar flavor to the graphs earlier, is our macro attention in language averaged across firm is the blue line on these graphs. And then the black lines are respectively the unemployment rate and the detrended level of the S&P 500. And below are the scatter plots of the relationship between these variables. So macro attention seems to go up in times of crisis and to go down in times of boom. And then finally, at the microeconomic level, so this graph by itself communicates that at the macro level, attention and misoptimization are going with one another. But we can do a more stringent test. If it's truly the case that these are measuring two sides of the same variable as we're hypothesizing, it should also be true at the micro level if we zoom in on individual firms. So we're going to run this firm level panel regression between the squared misoptimizations of firms and their level of macro attention. And we're going to sweep out not just the aggregate trend, but for sector-specific trends using these chi j of I, comma t fixed effects. And what we find is a negative relationship at the micro level between macro attention and misoptimization. So what I'm showing here is the bin scatter plot corresponding to the panel regression drawn above with no additional controls. And again, in the paper, we discuss in some more detail how this result is quite robust to including even more stringent controls for firm level fundamentals. Okay. So in my remaining 5 minutes, I think before opening things up for 15 minutes of Q&A, I want to talk about our quantitative exercise. So what we've established so far is that consistent with the theory, there seems to be a cycle of misoptimization. I alluded to the fact that this could affect macro dynamics in terms of business cycle asymmetries. So a completely natural question is exactly how much does that add up to quantitatively? So to calibrate our model, we're going to say that the productivity sufficient statistic is a Gaussian AR1 in logs. And there's 6 parameters that remain to calibrate. There's slope of the wage rule, the elasticity of substitution, and the persistence of productivity we're going to take from relatively standard sources. The 3 parameters that we're going to match using our own estimates are first, the coefficient of relative risk aversion. Second, the average attention cost in the economy. And third, the variance of productivity shocks. And what we're going to match are the average level of our misoptimization dispersion. So we can take that seriously as a measure of how misallocated the economy is. Second, how much that moves with respect to the state of the economy. So in particular, the slope of that with respect to the unemployment rate will be our preferred statistic. And then finally, the variance of quarterly real GDP growth that'll just give us the right size of fluctuations in the economy. This graph summarizes our main findings. So the black solid line is our attention cycles calibration. And what the graph shows, respectively, is aggregate real output in the economy as a function of productivity. In the middle, the attention wedge, or the difference with the RBC model. And in the right, aggregate labor productivity, or aggregate output, log of aggregate output divided by aggregate labor. The dashed line for reference is a purely RBC calibration of the model to compare with the AC, or attention cycles calibration. The median output cost of inattention we estimate to be about 2.6%. The productivity cost is 1%. And moreover, we see, as predicted by the theory, this widening attention wedge that makes that cost much larger in high productivity states. Finally, the attention wedge is concave, which is going to imply more shock responses in low states of the economy. So much so that labor productivity is actually non-monotone, which we think is a potentially appealing prediction for matching the data. So to zoom in on that even more, what I've plotted here is the sensitivity of output to the productivity shock relative to the sensitivity in the median state. So that is to say, this is normalized to be 1 for the median productivity state, and it conveys that shock responses are 5 to 10% higher in low states and 5 to 10% lower in very high states. Similarly, the conditional standard deviation of output growth in 100 times log points, due to really the same underlying mechanism, is going to be higher when the economy is in a low state. That's when firms are attentive. Output is more responsive to productivity, and lower when firms are in a high state. And in the paper, we do some more careful benchmarking of these results relative to the literature. And the headline finding would be that both panels give you about 15 to 20% of what statistically other authors have estimated as the realistic amount of asymmetry and state dependence in business cycle fluctuations in the United States. Okay, so to wrap up and to allow some time for questions, in this paper, we've introduced the theory of attention cycles. we showed that firms, we created a model in which attention and misoptimization cycles were firms' rational reaction to higher stakes in downturns. And moreover, they translated into a mechanism for cyclical misallocation in the economy. In the data consistent with the theory, we found direct evidence of pro-cyclical misoptimizations and state-dependent market punishment of misoptimizations. So that is to say, we found the attention cycle as hypothesized and evidence of an incentives-based mechanism as we hypothesized. And finally, quantitatively, we showed that in a model that matches these facts, endogenous attention magnifies aggregate shock responses in low states of the economy, and it can go towards solving some empirical puzzles about why the economy seems to have, say, fast crashes and slow recoveries. In companion work, which I referenced a little bit in the middle of this presentation, we dive a little bit more theoretically into the models of strategic mistakes, of which our attention cycles model is one example. And we study additional macro and financial applications, including speculative investment and price setting. And we think that this modeling technology could be one that's quite useful for a host of problems in which we want to take seriously the responsiveness of attention to incentives, but we also want to do tractable equilibrium analysis and take things to the data very directly. And just to say, in other ongoing work, Joel and I are very interested in kind of studying other aspects of bounded rationality for firms, including firms' herd psychology. We have a new paper about the macroeconomics of narratives, and we want to come at that with modern methods and tools. And I just want to once again say thank you so much to the organizers, and I hope I've left enough time to take all of your questions.
Thanks so much, Karthik. That's terrific. So currently, that's so nice. And now we are opening the floor for more questions. If you have any questions, please feel free to raise them now.
One small question, because the result of this paper heavily relies on the assumption, the CES assumption, the production function, which is CES, and the productivity sufficient statistics. It also features a CES form, right? Mm-hmm. So what I'm thinking is that, well, if you consider the leader of any given specific industry, mm-hmm. so what you're going to observe is that it's going to be a first mover and then follower strategy. So when the leader or the top one player adopts a new strategy or has a new form of attention, then the followers, the second, the third, and the other smaller firms, they're just gonna do the same thing, quite the same. So when you take that into account, does that lower the importance of attention in this model, or the model predicts?
Mm-hmm. Yeah, so that's a really good question. So just to unpack that in a few different parts and tell me if this addresses all the facets of your question. So your first observation was that we're using a pretty specific structure for demand and for aggregation. And you're totally correct that that was referenced a few times in the presentation. I just wanted to flip back to this slightly more general result that we start with, which is that this observation at the micro level, that what firms do depends on marginal utility and profit curvature. This would be true for other shapes of the demand function, including demand functions that are qualitatively different for, say, leader firms and follower firms in the economy. And insofar as the marginal utility channel seems really dominant in our calibrations as well as our empirical analysis, that might suggest to us that, even if firms are a little bit different in the demand curves that they face, the mainline force that leads to the attention cycle is pretty constant for different types of firms. Now, in terms of your more specific predictions about leaders and followers, I think that's super interesting. It's not unrelated to some of the work that Joel and I have been trying to do recently on narratives and herd psychology. I think your interpretation is totally reasonable, but I might also suggest the alternative, which is that in a world where business managers tend to follow leaders, those who are particularly influential, either socially or otherwise, are leaders in the market, perhaps leaders can make the economy more sensitive to attention cycles if they start, going on earnings calls and talking about cleaning up their companies and cost cutting and taking aggressive measures and stuff like that. If all other firms in the economy want to imitate them, that could actually amplify the dynamics that we're studying. So I think it's actually interesting that, to me at least, I see some predictions that could go either way with those kinds of enrichments.
Yeah, the reason I think of this question is because the leader has a higher profit curvature, right? But the followers, even only the second one, the profit curvature is much smaller. I'm just well, it might not be the case in reality, but well, this is just my guess.
Yeah, and that's interesting. But there's also again, it could go the other way. It could be that the elasticity of the leaders face more inelastic demand if they've done a lot of consumer acquisition and they have a lot of captive audience, if you'd like, and the followers can lose demand more easily if they make mistakes or misprice. But I think a more careful study of exactly the mechanism that you have in mind could be super interesting. Really allow profit curvature to differ across types of firms, and that could shift over the cycle. And yeah, I just want to say I think that's a great direction to go. And this is as far as maybe we have gone on those issues.
Thank you.
Thanks.
Hello.
Hello.
Hi, Karthik. This is Long Chen from Luohan Academy.
Wonderful.
I really like your paper, and I think it's one of the few papers that uses the psychology, the human nature, to explain economic activities, because we know it's important, but in economics, a lot of time we are restricted by our discipline, the implicit assumption that we are rational animals, but we're not. So I really appreciate that. But I think basically my take of the paper, essentially it says that people are more stupid and they are more aggressive during the boom period. So I think to me it makes a lot of sense. I used to be a professor. Now I'm in the business for like many years, and so I think it's utterly clear that during the upward trend. Sorry, can you hear me?
Yes, I lost you after upward trend.
Yeah. So during the upward trends, people makes a lot of the stupid mistakes. So I guess I would like to. So it makes a lot of sense. But so I think of course you have assumptions, but I think you can. Firstly, I think to me there's three sides to go. One is that at the fundamental level, I think you can further link to the psychology or to the behavioral economics things to further extend what economists think about this issue. That's one side to make the thinking more profound. On the other side is the implication. But I think I would like to push you to think further. What is the implication at the macro level and at the micro level? So what? That's my. So you have your model. Sounds cool. So what?
Yeah. Thank you. Thank you for the comments. I think what we're emphasizing right now is that this can make the business cycle in the aggregate more asymmetric, that it can lead to faster crashes and slower recoveries because of this movement of herd psychology and to borrow your phrase, this relative stupidity of business managers and decision makers in booms. So that's the angle we've emphasized right now. But we can also go in some other directions using the same idea and different sorts of macroeconomic models. So your comments are very appreciated in terms of kind of where we can go with this research.
Yeah, so basically what I'm talking about is about the follow-up, because we don't want. Sorry. So we don't want to have just a pretty model, but doesn't really have so what part. I think on the macro side, you guys are exploring a different angle. We want this to be beneficial for the decision makers, macroeconomists, and so I think that can go far. On the business side, I think also we can have important implications, measures of the health of the decision making and stuff like that. So there are many things to do and to test. But at this point, I think it's elegant to talk about things, but it's not clear to me what can be done about this.
Yeah, and I think it's also very interesting. I didn't talk so much about the normative implications of this theory, but one possibility is that, if all of this reflects cost-benefit analysis on the part of firms, it's not clear that a social planner could do better by intervening. I have some other work with Marios Angelitos about this topic in kind of more general aero-debris settings. And what we show is that there's a large class of economies with cognitive costs, including the one that we study in this paper, in which even the social planner could not necessarily do better. Because at the end of the day, these fluctuations in decision quality are individually optimal for people, and externalities net out in settings like this that are very neoclassical. But I think more exploration of that issue and more natural and more extended models would be interesting, because I agree with you. It completely begs the question about, from a business perspective or a social perspective, what we ought to do about it.
Right. So externality is the important angle from the macro and the micro implications. I look forward to your further work. I think makes a lot of sense. It is time that economists that get back to the human nature, because this is economics is about economic human activities. So it's cool.
Yeah, thanks so much. And as you say, we're sort of deeply inspired by that work.
Can I ask a question?
Of course, yes.
Hi, Karthik. Great. It's a great framework. It's a very fresh perspective to connect the information, attention, and business cycle. I have a more kind of probably a technical question.
Okay.
So you consider the entropy-based information technology, and I'm thinking that typically this kind of information models are very sensitive to the learning technology. So what if you choose other kind of learning technology? For example, you pay cost to acquire precision, so the result can be very different, and so maybe even the direction can be different. Like what Laura Wedekamp and Stein they have shown the results. So this is kind of the first general question, kind of sort of. So this is more like a direction, qualitative result. So if you change the information technology, the result might, even the direction might switch. The second one, so I think this is a very elegant framework. I mean, so this parameter lambda is same. It seems you don't calibrate that. It's more like you estimate 3 kind of parameters simultaneously to match the models. I want to kind of understand, so what's the more economic or intuitive interpretation of this lambda? So you match this lambda maybe -3, -4, and I don't know how to interpret that. That's kind of more not like learning cost. If it's a learning cost, I sort of know the idea. So you pay $100 to hire an analyst and produce a precision. So here, this lambda is very abstract. I don't know how to ex-ante to gauge the kind of the plausibility of this parameter. It's not a very kind of intuitive. This is kind of my 2 questions about the learning technology. No, I want to see your thought. Thank you.
Thank you so much for your questions. So in the interest of time, I have to be a little bit brief, though I'd be happy to continue the discussion anyway. So, okay, in terms of other learning technologies, so the result pretty much as is will generalize to the whole class of what we call state separable costs, which share a lot of features with the entropy cost, in particular that they're additively separable across different states of the world. In the paper, we discuss a little bit what would the world look like if we had a more general, for instance, posterior separable cost of learning, which would encompass the mutual information model, not necessarily the precision cost model. And we show that the partial equilibrium logic is still intact. You still, in some well-defined way, want to make your actions more precise in these high stakes states, high curvature states. What we lose is the ability to show exactly what the optimal policy is and to aggregate that in equilibrium. So I think there are some open questions there. Qualitatively, the partial equilibrium results we think would work in a bigger class of learning technologies. That more specific question about the work of Veldkamp and Van Nieuwerburg, I think is really interesting. So they use precision costs, but actually I would suggest that that's kind of not the main explanation for the result, which is qualitatively different. It's instead that the sources of information in the economy are exogenously moving over the business cycle. So if you'd like, we're giving people access to the same amount of information or same decision quality at all points in the business cycle, and we're moved entirely just based on what firms want to do and what they want to acquire. So it's a completely different margin. Oh, and finally, the interpretation of lambda. I agree with you. So the right interpretation would be it's kind of like it gives an indifference curve in units of profitability or stock price for firms about how much to achieve a certain level of precision, what's the as-if translation into the valuation of the firm. And I think we could do more to bring that out. Off the top of my head, what I know is that the cost of inattention relative to being perfectly attentive is about, in steady state, 3% of the profitability of firms. So I think that it's not exact, but that helps back out order of magnitude what our lambda sort of implies. Lambda is such that people tolerate that 3% loss because to get rid of it would require too much cognitive effort. But we could definitely report something. It's a great idea that gives that a little bit more of a dollar interpretation. It's definitely possible.
Great, thanks.
Yeah, this is also related.
Can I ask us?
Yeah, please go ahead.
Yes.
For Karthik, can I ask a quick question? It's like I noticed that the way you measure attention is very similar to how people measure uncertainty. And I think this can go another way. Like in your model, the shock is like FOSD shock. But if we have like a mean spread shock, like people pay more attention when there's one uncertainty, it's also like a natural, right?
Yeah.
So I guess, yeah.
Yeah, no, that's totally right. And we think it might be an interesting result, actually, that we show that attention spikes when people have measured volatility in the economy, which is one interpretation of uncertainty going up. In terms of the language measurement, I agree with you. So just to get into the weeds very quickly, we don't, a lot of those papers search for kind of topics used in proximity, like within 10 words, for instance, of a word that conveys uncertainty in English, like maybe or perhaps or similar. We don't. So we would be getting, we think this broad-based measure of attention, which kind of sums over sentiment, uncertainty, and a lot of those interpretations is the correct one. But it would be interesting to zoom in further about, decompose macro attention into uncertainty, sentiment, and kind of other sensible categories, and to see how those individual streams of macro attention move over the cycle. And I think one clue is that our macro attention is way more persistent than macro uncertainty, say measured by Baker, Bloom, and Davis. So that series really spikes in a few events, but it goes down quite quickly. So it's high, in October 2008, but it's actually quite low in, January 2010, excuse me. Versus ours is much more low frequency. So that might actually come out of doing that analysis more carefully.
Yeah, great. So is your model like implicating like there is a counter-cyclical misallocation and the markup? Is your model saying that?
Say that again, sorry. I didn't quite hear you.
I mean, the implication of a model, are you saying that there is like counter-cyclical misallocation and markup?
Okay. There is pro-cyclical misallocation in this model. And markups, it depends how you measure them. Average markups are going to be the same at all points in the cycle. But because of misallocation, you might, by averaging, a wrong sense of that in terms of profit shares.
Yeah, great. Thank you. I enjoy your presentation very much.
Hi, Karthik. Sorry.
May I ask a small question?
Okay.
Please, yeah.
As for the entropy measure of the cost, well, if you change it to other measures, providing it's additive, it might not change the result much. But what came to me is that, well, if the managers do not know the state tomorrow, then that's one sort of risk. But in many situations, it is not because they don't know the states are over there. It is just they do not know what will become of tomorrow. And if you consider this kind of uncertainty, which is called latent uncertainty, and to tackle this by using, for example, non-additive probabilities, it's going to change the result quite a lot.
That is fair. Yeah. And that's not, that is not formally a model that we have considered too much. And it would be interesting to kind of lay them on top of each other. So maybe one conjecture, just, to entertain that possibility, is that the space of models that people consider could expand or contract in downturns versus booms. But then within each model, they're doing something like what we're suggesting to come up with the correct course of action. So they can consider more models of the world, but then how they make decisions conditional on a model of the world changes in different states. I think would be interesting. There is also one connection that I should flag, that a lot of work in decision theory, like the paper of Fudenberg, Ijima, and Strzelecki in Econometrica, shows that our class of control costs can have an ambiguity aversion interpretation. But I think we could do a little bit more to think about, once you apply that, what our results imply, and whether there's other factors that would be natural once you start thinking in those dimensions.
Yes, it's going to make the model infinitely more difficult to build. But meanwhile, what I'm trying to say is that, to put it in a simpler way, it is not because the managers do not want to be attentive. It is because, they do not know how, they do not know what to focus on, or they don't even know what will become of tomorrow. So where should they put their attention to? They don't know that. Yeah.
Sure.
So there's a difference between inattention and, they don't know where to put their attention to.
Yep. I agree with that. Yes. Yeah. And I think exploring that in more detail would be really interesting. It's consistent with some of the psychological foundations, but it leads in a different direction in terms of the mathematics and the possible implications. Excuse me.
Yeah. Yeah. Thank you.
Thank you.
I also have a very quick question. It's about the measurement.
Okay.
I kind of think of a different setting. What if companies just attribute that bad performance to macro conditions during bad times, while attributing good performance to themselves during good times? Will this cause some bias in the measurement? Totally.
So for our language-based measure, that's also one reason why we don't want to rely entirely on the language-based measure relative to the misoptimization-based measure. But, and I don't doubt that there's some bias coming from the channel that you suggest. One thing that is interesting, and it suggests that your channel isn't dominant, is that in the cross-section, the more macro-attentive firms, the ones that your hypothesis suggests should be blaming the macroeconomy, actually have smaller misoptimizations, which, as we've shown, are misoptimizations are bad for profitability, stock returns, etc. So we have a micro level result suggesting that the attentive firms are doing better, which is a little bit inconsistent with a strong role for the blame channel that you suggest, but I don't doubt that some amount of it is true.
Thank you.
Yes, and indeed, we have run out of time. I'm really sorry about that, though I'd be happy to follow up in other channels.
Great, thank you so much, everybody, and thank you, Karthik, for bringing us these terrific topics. I hate to interrupt, but we've already run out of time. So thank you all for coming, and thanks again, Karthik, for today's fantastic talk.
Well, thank you. It was my pleasure. Have a good night, everyone.
Bye, everyone.